Hi everyone, welcome to the part 2 of thermodynamics. Actually, thermodynamics chapter is very huge chapter, so it is not possible to complete this large chapter in one shot. So that's why I'm making this video. If you read this two parts before your exam, this is more than enough. Okay, you don't need to read anything out of this two parts. Okay, and most of the students are asking to make videos on organic chemistry. Actually, organic chemistry is not possible. Why? Because I don't know how to make short notes for organic. So because if you see in organic, so many named reactions are there, reagents are there. Okay, so organic, in terms of organic, we have to practice a lot. If you take even so many teachers, okay, including me, so everyone generally suffer with organic. So the only thing, if you want to overcome your fear in organic, you have to practice a lot. Okay, that's the only thing what you have to do. Short notes is not that possible, but I will try to make short notes, but I don't know, I'm not getting to know how to make short notes for organic. I will try. Okay, so let us start. Okay, so first Euler's theorem. So z is a function of x comma y variables, right? X comma y. So in place of this x comma y, examiner can give you a variables. For suppose temperature is a function of pressure and volume, like that. Okay, so z is an exact differential. So then if you want to find out, then you have to use this formula. This is the Euler's formula. So dou by into dou z by dou x at constant y at x. Okay, dou by dou x into dou z by dou y at constant x at y. Okay, so this is the first formula, important formula. Next, Kirchoff's equation. Kirchoff's equation is also very important. Delta H2 minus delta H1, enthalpy change, equal to delta Cp into T2 minus T1. Examiner will give you the values. You have to use this formula and put your values here. Or delta U2 minus delta U1, internal energy change, equal to delta Cb, okay, into T2 minus T1. Next, Carnot engine. Carnot engine, very important, and this formula is very important. So total work equal to minus R ln V2 by V1. You have to put the value R equal to 8.314 joule per Kelvin per mole, and minus R ln V2 by V1 into TH minus TC. TH minus TC means temperature of hot source minus temperature of sink. Temperature of heat engine minus temperature of sink. And efficiency of heat engine. Efficiency of heat engine is always less than 1. If you calculate efficiency of heat engine, you always have to get less than 1 value. Okay, then only your answer will be correct. Otherwise, your answer is not correct. So according to this, you can eliminate your options too. Okay, so efficiency of heat engine is less than 1. That equal to TH minus TC by TH, equal to Q1 plus Q2 by Q1, equal to minus W by Q1. Okay, these three formulas also belongs to heat engine, efficiency of heat engine. And next, these graphs, you have to focus on graphs by yourselves. Okay, so first graph, I am taking this just enthalpy or internal energy or temperature on y-axis and entropy on x-axis. If you draw a graph, your graph will be like this. Okay, next, internal energy or enthalpy or temperature versus volume, you will get this kind of graph. Okay, focus on graphs. Next, adiabatic reversible process or isothermal reversible process. Okay, in these two cases, if you have adiabatic reversible process or isothermal reversible process, in these two process, entropy change of universe is 0. Delta S universe equal to 0. And for irreversible process, delta S universe is greater than 0. Okay, these points also important. You have so many formulas regarding delta S. So I am giving all formulas of delta S. You have to note down these all delta S formulas in a sequential manner. Okay, next, entropy change, delta S equal to, if examiner will give you the temperature range, T1 and T2 temperatures will be given to you, so then you have to use this delta S formula. Delta S equal to integral over T1 to T2 n Cp by T dt. Okay, number of moles, heat capacity at constant pressure, temperature. Okay, so you have to this formula, delta S equal to integral over T1 to T2 n Cp by T dt. Next, inversion temperature Ti equal to 2A by RB. Okay, examiner will give you the A and B values, right? You have to use this formula to calculate this inversion temperature. If experimental temperature is greater than inversion temperature, then heating will take place. This is the Joule-Thomson experiment. Okay, if experimental temperature is greater than inversion temperature, by using this formula you have to calculate inversion temperature. If your experimental temperature is greater than inversion temperature, then heating takes place. Then in that case, Joule-Thomson coefficient mu Jt is negative, that is μ is less than 0. If experimental temperature is less than inversion temperature, then cooling takes place. In that case, joule Thomson coefficient equal to positive, that means μ is greater than 0. Okay, next delta S equal to, if examiner will give you the enthalpy change in temperature, you have to use this formula, delta S equal to delta H by T. Okay, this is also important formula. Next one, entropy change of mixing. Okay, so entropy change of mixing, delta S mix equal to minus R summation of Ni ln Xi. Here Xi is nothing but mole fraction equal to number of moles by total number of moles. For suppose you have N1 moles and N2 moles, then X1 equal to N1 by N1 plus N2. Okay, you have to use like this. Okay, or if you want to get in log, if you want to get this formula in log, so you have to write minus 2.303 R summation of Ni log Xi. Okay, minus 2.303 R summation of Ni log Xi. In terms of ln, you have to use this formula, minus R summation of Ni ln Xi. Xi is the mole fraction, number of moles by total number of moles. Next, Clapeyron equation, dP by dt equal to delta H by T delta V. This equation you can use in, you see generally in phase equilibrium, right? So Clapeyron equation, very important formula, dP by dt equal to delta H by T delta V. Next one, spontaneity, criteria of spontaneity, delta S universe, change in entropy of universe is greater than 0 for irreversible process, equal to 0 for reversible process. That means greater than or equal to 0. Delta S universe greater than or equal to 0, greater than 0 for irreversible, equal to 0 for reversible. And this is Maxwell thermodynamic square. You already know entropy, pressure, temperature, volume at the corners, and here internal energy, enthalpy, Gibbs free energy, Helmholtz free energy. So if you take the change of internal energy du at S comma V, see du, u here, u is in between S comma V. So du at S comma V is less than or equal to 0. This is the first criteria of spontaneity, and this criteria of spontaneity is very, very important. You have to remember these equations, right? Next, dH at S comma P is less than or equal to 0. dG at T comma P is less than or equal to 0, and dA at V comma T is less than or equal to 0. And next one, dZ. Okay, so dG at T comma P less than or equal to 0. Next one, ds at U comma V. ds at U comma V greater than or equal to 0, and this ds at H comma P is greater than or equal to 0. You have to focus mainly on these two also. Okay, so remaining all equations are less than or equal to 0. These two are greater than or equal to 0. Next, delta G equal to nRT ln P2 by P1, which is equal to nRT ln V1 by V2. Okay, so in terms of pressure, you have to write P2 by P1. In terms of volume, you have to write V1 by V2. Next, fugacity. So fugacity equal to phi into P, right? So this phi is nothing but your fugacity coefficient. So fugacity is nothing but real pressure, right? So here mu equal to mu naught plus RT ln P by P naught in terms of ideal gas. If you have the ideal gas, you have to write this equation, mu equal to mu naught plus RT ln P by P naught. Okay. If you have the real gas, examiner if mention the real gas, you have to take in terms of pressure, you have to take fugacity F. So mu equal to mu naught plus RT ln F by F naught. Next formula, ln phi. If you want to calculate the phi value, ln phi equal to integral over 0 to P z minus 1 by P dP. This z is nothing but your compressibility factor. Okay, z is nothing but compressibility factor. So ln phi equal to integral over 0 to P z minus 1 by P dP. Next one, for spontaneous process, this chemical potential mu alpha is greater than mu beta. This formula is also very, very important. Next one, delta G mix. This is also very, very important. Gibbs free energy of mixing. I have already discussed about the entropy of mixing. This formula is Gibbs free energy of mixing. Here minus is not there. Okay, and T is extra here if you compare with entropy of mixing. So delta G mix equal to RT summation of Ni ln Xi in log 2.303 RT summation of Ni log Xi. Again, mole fraction equal to number of moles by total number of moles. This Gibbs free energy of mixing is always negative. Okay, according to this, you can eliminate the options. Entropy of mixing value always positive. Gibbs free energy of mixing value is always negative. You have to get only in negative, delta G mix. In entropy of mixing, you always have to get positive value. Next, delta V mix and delta H mix, right? Enthalpy change of mixing or volume change mixing. So this 0, delta V mix equal to 0, delta H mix equal to 0. This is also important. Last one is Gibbs paradox. For same gases, if gases are same and asking to calculate the entropy change of mixing, then delta S mix is always 0. Okay, delta S mix is always 0. This is very, very important. This on this formula question asked in GATE also. Okay, number of times asked in GATE, so you have to focus on this formula. So for same gases, delta S mix equal to 0, right? So that's all for this video. If you study these two videos, this is more than enough. Okay, I have covered everything here, everything in these two parts. Okay, so this is more than enough. Thank you so much.